Hello again, and welcome to my next session, which is the Enterprise Mobility Services Overview. I'm JT, Senior Director of Application Developer Products, and I'm responsible for all the developer product management and product marketing here at Embarcadero. You can contact me at jt@embarcadero.com. Twitter handle is @FireMonkeyPM, and there is my blog URL. So in this session, we're going to basically get into Enterprise Mobility Services. What was the motivation behind it? What were the challenges enterprises are facing that drove the requirements and features of enterprise mobility services? Then we'll dig into what those features are and from an architectural perspective, and also what each of the individual features do. And then we'll do a demo and we'll take some questions. So let's jump right into it. So as we talk to enterprises and analysts and try to understand a bit more about the types of challenges enterprises specifically are experiencing when they try to mobilize, there was some pretty consistent challenges that they all faced. And basically these are the key ones that we focused on resolving or addressing in this first version of Enterprise Mobility Services. The first is that enterprises need to securely access data from back-end databases kept behind their firewall that they manage, that has their intellectual property living in it. They need to be able to securely move that to a mobile device and keep that information secure on that device. So security was pretty important, but so was getting this data from behind their firewall. The other thing that they've told us is a big initiative is exposing custom APIs. And this is both for their own developers as well as third-party developers. So this was a pretty consistent trend in order to build new apps or to expose infrastructure and services to other developers and applications. They're exposing them through custom APIs through standard REST. The third thing that we heard is that they have all sorts of different databases. So they need access to all these major databases like Oracle or Sybase, Informix, SQL Server, so on and so forth. They need high performance access to these, and they need broad support for a number of these. And the final thing that we heard was they need to be able to analyze how their services are being used by users. So understanding which services are being used most, how often they're being used, by how many users. These types of analytics were critical in understanding who's getting into the system, who has access to these services, and finally how they're being used. So given those requirements and challenges, we've built Enterprise Mobility Services. And there was an additional feature, if you will, that we wanted to provide, which was we wanted to make it really easy for a development team to be able to build this type of service and deploy it into their enterprise. Now, of course, you do need IT help at some point once you're ready to go public with your service, deploying it into production. But by and large, we wanted developers to be able to build, develop, test, and then easily pass on something to IT that could then be taken into production. And we call this a turnkey middleware server. In other words, all the pieces are there to make it easy to build and deploy these existing services. So some of the services that we provided to help address these challenges include user management and authentication. So being able to know who has access, authorizing them access both by username and by group level, and then being able to use that information later on in analytics. So that user management was a pretty important piece. The other piece, and this was related to custom APIs, was being able to load modules or add new modules easily without affecting the production server, and basically to deliver custom APIs via the REST protocol. We also deliver our enterprise SQL data access technology, FireDAC, to access all these major databases. But then we provide an additional mechanism to access that data through REST APIs. So this is similar, if you use DataSnap, similar to how DataSnap publishes data through its middleware. EMS does the same using standard REST APIs. And then lastly, we needed to address the secure data storage issue. And so EMS includes licenses for our mobile embedded interface to go products, as well as SQL or server-side SQL data storage and interface server. Now, EMS itself is run by an interface server, as is access to a full interface server for the number of users that are licensed. But we also, again, provide those drivers for all the other major databases. And the final feature that we've introduced is, and service for that matter, is a console for analytics, being able to see who the users are, which devices they're using, and which APIs they're calling. So let's take a closer look at how this looks. EMS itself is made up of plugins, pluggable modules that you write in Delphi or C++ Builder, and you deploy into an IaaS server instance. Additionally, you deploy along with it the Enterprise Mobility Services database, which is powered by Interbase. So the combination of those two things, at least one module and the Enterprise database, is an EMS middleware server. If you want to add more custom APIs, if you want to add more data access, then you would create new modules that can be deployed into a live production system to enable access to those APIs. And then you use the user management facilities within the database to say who has access to these resources, and either at the username level or at the group level. So the EMS database is also what powers the EMS console. When the console goes in and says, okay, what users are connected to the database, who's accessing which REST API calls, it's querying that EMS database for that information. So that's the turnkey part of delivering an EMS server. On the back-end side, you have your FireDAC drivers that you use then to connect to your major SQL database or your Interbase server. And you can also integrate cloud services in the middleware layer. These can be integrated pretty much at any tier, whether it's the client itself or here in the middle tier. But this is an optional way to connect into backend as a service providers, for instance, to do push notification through the middleware itself and not at the client. But speaking of the clients, this is the other part of EMS, which includes the Interbase to Go database, the secure embedded database. And using the REST APIs and using the backend as a service components, you access these middleware services through EMS. So today, I'm going to demonstrate, for example, creating a REST service that doesn't require logging in. So I just use the basic REST client for that. But Marco and Jim in later sessions are going to talk about using the EMS provider or backend provider components to be able to do the user authentication and management, as well as the data access through with the user rights. So this is the basic overview and layout of what is EMS. To dig a little more into the user authentication analytics, user authentication again is managed a lot like most authentication systems, where you have a set of users, and users belong to groups, and those groups have certain rights, read or write or execute rights for a given resource. It's a lot like if you're familiar with the Linux file system, using ChangeMod, for example, to be able to set rights on a user, group, or other level. So it's a very similar concept in terms of user management. The authentication then can happen through password or through connecting into some other type of directory service. Then with the analytics, this will show you when calls were made into the service, which service it was, which API call, which users were accessing that service, and you can do this over any length of time that you'd like, or as granular as you'd like, to really understand the usage of that particular resource. So that kind of lays the groundwork for what EMS is. Let me give you a quick example, a quick demo of how this works. I'm going to create a basic REST service, creating an EMS module. This is going to be a standalone server, so I'm not going to deploy it into IIS, but rather in a standalone executable. Then I'll create a client that makes a REST call using the low-level REST components. And like I say, in the follow-up sessions, you'll see how to use the backend provider to do your user authentication to get access to that resource as well. Okay, so let's jump into RAD Studio, and I'm going to create a new C++ EMS server by going into the gallery and selecting Other, looking under C++ Builder Projects, selecting the EMS folder, and selecting the EMS project type. So this wizard allows me to create a package that can be installed into IIS that will allow me to publish an API, which we call a resource. So I'm going to create a package with the resource, and what I'm going to do in this example is I'm just going to reverse a string that gets sent to me. So I'm going to call this resource name reverse_string. And then I'm going to tell it I want a couple of endpoints. I want the get and the get item. And what you'll see here when I create this under the header file is both the get and get item handlers. And in my C++ file, you'll see that get item actually grabs a parameter for me and names it item. So the way that I respond to this is by using the response. Oops. And you can see that the response right here is the variable that I want to use. So a response, and I want to modify the body of that return, and I want to set a value. Now the set value takes a tJSON value and a boolean. So the tJSON value that I want to send is a tJSON string. And I'm just going to pass back item, and I'm going to pass back true, or we can use C++ style true to this function so that it knows that it handles the lifecycle. Oh, good point. Compiler, thank you for letting me know. It is expecting a pointer type. Okay, so now the server's running. This is my log that you see here. And if I go ahead and open it in a browser, it will ping my server, which is running on localhost 8080. And this is an automatic endpoint built into it. So the endpoint we just built is called reverse string. Okay, and by itself it doesn't do anything, but if I do a / and pass in a value, and this is the case, the name foobar, I'll see that it returned exactly what I put into it, because that's what I did in that code. So now let's go back in here, and what we're going to do is we're going to send the reverse of that string. So in here we could use the string utils function reverse string, and that is found in system.stirutils.hpp. Okay, let's look at this again. We're going to go ahead and pass in the exact same stuff, and now you see the return of that reverse string, raboof. So if I want to do this in pure C++ and not rely on the Object Pascal RTL functions like reverse string, first thing I'll need to do is I'll need to create a standard W string, and we'll call them WS. And we're going to pass it item. Now the reason I use a wide string is because string in the Object Pascal RTL is a Unicode string. So let me make sure I include string. I also want to include algorithm because we're going to use the standard reverse. Okay, so now we're going to call standard reverse on this. And we're going to give it the two iterators begin and end. Okay, now we have a reversed standard string or wide string, and we can pass that in here by calling the C_stir, which will send back a pointer to the character array. And we should be ready to go. Let's go ahead and build this. Okay, got a compiler error, and oh, I know what happened there. I need to send the byte array over on the other side of the conversion. So these are converting between RTL functions here. So open the browser, and let's try that again. Okay, so now we got it working in standard C++ as well. And what you may have noticed also is each time I call the resource, it does get logged here in the console. So let's go ahead and do reverse string a couple of times. And I'll put another one in here, C++ builder. Okay. And so we see that this gets logged. This will be what ends up showing up in our console when we go to see who called which resources and which resources they called. So now that this is running, let's go ahead and create a new client. So let's go to the project group here. Actually, we'll go back up to the project group and create a VCL project. C++ builder, VCL forms application. Okay, so now that we're in our VCL form, let's add a button, and we'll add an edit control. And the idea here is dynamically we'll take something into the edit control, and when the button press we'll make that REST request back out and make that call. So let's get a REST client going first. And we can use these REST components because the EMS is a standard REST server. So the first thing we do is we provide the base URL, and this is the local host 8080 on which our local EMS server is running. Then we'll get a REST request, and we'll also need a REST response. So let's go back to the request here, and we're going to set up that resource. Recall I made one called reverse string, and for the sake of illustration I'm going to add the argument in here, foobar, because what I'm going to do here is I'm going to execute the call live in the designer here, and you see that the response got that back. So this REST call is actually being made in the designer and returning that result to me here in the designer. So let's change that just to show that this is live in the designer, C++ builder. And let's make that request again, execute it, great, and the response will show that latest information. So now let's make it dynamic in our button click handler. What we'll do is we'll make we'll set up the REST request resource dynamically. So we look for the resource, and we're going to say reverse string. And we're going to add in the whatever's in the edit control. Okay. Now we're going to execute that request, so REST request 1. And let's grab the execute call, and you'll see that there's two here, the execute async and execute. Async is an asynchronous call, which we would provide a callback, but we'll make a blocking call so we make sure it comes back in this case. And now in the response, we'll take the body of the response, which is called content here, and we will wrap that into a show message. And we are ready to run it. Let's go. Oh, let me make sure I'm on the right project here. And run. Okay, let's make that request. Oh, what's this? Oh, great error. This is actually a JSON error. And what it's telling me is that it concatenated reverse string in edit 1, but I forgot to put the / in there so it knows where the parameter is. Okay, so this will work now. And yep, edit 1 got reversed. Let's try foobar again, and we get back raboof. And one more, C++ builder. Okay, So what we just showed you was using C++ Builder to create an EMS server, setting up a custom API using a EMS resource, then creating a VCL application to make that call using the standard REST components. Okay, so now that you've seen it in action, let me tell you a little bit about how EMS compares to DataSnap. DataSnap has been the middleware or end-tier solution in Delphi and C++ Builder for many years. DataSnap is really should be seen as like an SDK. You can build everything you've seen here with DataSnap, but you build it yourself. It's an SDK with the parts to build these types of services. So you build your own server. You can create REST versions of it or even SOAP versions. You can also use FireDAC, but again, you're building these services. So for example, the user management is something that you would need to build. The analytics is something that you would need to build separately, but the parts are there for you to do it inside the DataSnap SDK. EMS, on the other hand, as we talked about, is a turnkey ready-to-use solution. You saw how easy it was for me to create a new resource, deploy it, and connect into it. And that's about basically the approach you just saw was creating server extensions, which exposes these REST APIs or data access through FireDAC via these standard REST APIs. So EMS uses a standard REST in JSON, which means it's fully stateless. There's no sessions, and that means that it's also more scalable and more robust because there's no session management that could cause issues. On the DataSnap side, there is session management. This is just the way DataSnap has been built over the years. Even if you're using REST, there's some session management. Now you do have options to not use sessions, but this is generally how the architecture was designed to be used. So that's a pretty big difference between the two of them. EMS includes the user management, the API call analytics, and the console. Again, DataSnap, these are things that you would have to build on your own. And similarly, they both are self-hosted solutions. In other words, neither of these are living on the cloud that we, Embarcadero, provide a service for you to subscribe to. Rather, you deploy it on premise or within your private cloud to integrate it into your existing systems. And so I guess the last difference that's worth mentioning is DataSnap is part of Enterprise or above. It is part of that license, so it's free deployment, but it's only included in the Enterprise SKUs and above. EMS is an alternative that is free to develop, but you pay per user for these additional services. But remember that it does include Interbase Server and Interbase to Go. So these are traditionally user-based licenses that are now part of the subscription to deliver these services, including all of the things that you saw with analytics, but also the secure Interbase embedded to go and the Interbase server. So just to kind of close and help you see the overview of EMS again, we're talking about a couple of key component pieces: the ability to build these plugin packages that get deployed along with the EMS database, that drives the EMS console, the FireDAC drivers on the back end to talk to all the major databases, the included Interbase server license for the number of users that you use, the included Interbase to Go license for your users as well, and then the accessibility through REST APIs or through the backend provider components. So this was just a really basic overview today. I barely scratched the surface. Highly recommend either one of these sessions in the C++ or Object Pascal track. Marco is going to talk about working with SQL databases at different times tomorrow. And Jim is going to talk about authentication and authorization at different times tomorrow as well, depending on which track you're in. So if you attend these 3 sessions, you'll have a pretty good understanding of how EMS works and how you can use it within Enterprise to deliver these sets of services quickly and easily. Okay, so at this point, I'm ready to take some questions.
Okay, JT is with me. JT.
Yep. To let you know, there are 2 really good examples in C++ in the product. Under samples under EMS, you'll find a FireDAC example for moving data back and forth, and you also find a notes sample, which is managing some notes on the back end.
And there's a question here. I like this one from James. I realize that you are not the salespeople, but can you give us some idea of the costs, which
Certainly.
you know completely about?
Yeah. So as I mentioned in the EMS versus DataSnap slide, the EMS business model is based on the capacity of your user base. So what that means is there's a pure user charge to use EMS versus DataSnap, which is only available in enterprise. There is no additional charge. So EMS provides that user management, provides these additional services that you saw today, but you pay for the number of users that are going to access it. The basic pricing is, you can find it on our site. It's basically tiered pricing, which we call like bronze and silver and gold, and it's up to a certain number of users. So the bronze, for example, is up to 50 users. That's the lowest tier for getting in, which goes for $49.95. And each additional license you buy after buying into that tier is $100 per user. You go to the next tier, which is silver, and that's up to 100 users, and that price, and don't quote me right now, is I believe, trying to remember the price, but it ends up being about $35 per user. And so the prices do drastically reduce the more users that you're using. Ultimately, we want you to have a conversation with a salesperson about it because it is based on your user count and your capacity needs within your enterprise. And the other reason why you need to contact or should want to contact a salesperson about it is because that's how you get access to the ISAPI module as well in order to test it in production. In the product today, you have all the parts you need, but the only deployment option is a standalone server, and that's not the most performant version of EMS. You're going to want to get the ISAPI module and deploy it into an IIS server for production. So that's at a high level what the pricing looks like. Again, a salesperson can walk you through that, and after having a conversation and understanding your environment, then you'll negotiate what that price will be. One thing to make sure that you're very clear on is that this does include interbase server licenses, which typically would be an additional cost otherwise, and also interbase to-go licenses for the embedded secure database, which again otherwise would be a per device cost. So both of those are part of the fee to access and use EMS.
There's another question here, JT. Does EMS do anything with encrypted storage on the device, or is that just part of the enterprise interbase to go?
Well, it basically is delivered by the interbase to go that has the encrypted per field encryption built into the database. So that's how it's delivered today. Certainly that data store can then be converted into or worked with your client to convert into the JSON that you want to pass back and forth with EMS to share it with your interbase server or other server out on your server side. But yeah, that capability is delivered by the embedded interbase to go database today.
And Stephen Ball is doing a session in both the Pascal and C++ tracks on using IB Lite in a mobile environment and also interbase to go for secure.
Right.
So there'll be a session you can look for by Stephen Ball for additional information as it relates to the interbase parts, both in EMS and in mobile applications.
Yep.
The other thing I remember, JT, as it relates to user management, you can have that interbase user database somewhere on a server so that if you have, for scalability, multiple EMS servers can use
a common EMS
database for the user licenses.
Yep.
So you don't have to have a user license database on this EMS server instance and this EMS server instance and so on.
Absolutely correct. And it's not, there is no charge for the number of servers anyways, but yeah, that's a smart way to manage a common user base or use a additional directory service like LDAP, for example.
And then in EMS, the communication is HTTPS, or it could be HTTP if you're inside your firewall, or HTTPS.
It could be
right?
either one, yes.
Yeah. So you can choose, again, the port and the HTTP or HTTPS protocol for the REST operations.
Right.
And again, the Interbase to Go edition can encrypt either on server, desktop, or mobile. It can encrypt at the database level and at the column level. So I think you used the word field, but column, table, and database. Not rows, because it doesn't quite make sense how many selected rows and so on. But you can encrypt columns and tables in a database. So you can look at, there's more information in the doc wiki and on the interface side about the additions and the to-go and the server editions and what encryption. We ship out of the box DES just because of export license issues, but you can go way up to AES 128 or whatever as choices.
Yep.
Yeah. So again, the to-go edition can encrypt on the mobile side and server. I'm trying to type while I'm talking. That's bad. Okay. That was a question from James. Let me see. Other questions for JT? Again, this was introduction. And as JT mentioned, 2 more sessions on EMS. Jim Tierney, who directs the team in R&D that builds EMS, DataSnap, FireDAC, all the data access pieces, live binding, data binding, all of that. So he'll be doing the authentication authorization. And then Marco on if you want to choose to have interface or any SQL database that's part of what your EMS, when JT had that slide up where you can talk to REST services from your EMS middleware or Oracle database, SQL Server database, whatever the databases you might have with your customer data or whatever it might be.
And that's one to definitely see if you're working with data through middleware, because it's there's some surprising capabilities over REST, such as being able to manage the master detail relationship through the query and out to the client. So highly recommend that session to see what EMS can really do over standard REST.
And again, JT had that picture up. EMS sits in the middle. You can put business logic in the middle, but then you can connect to anything that you can connect to from C++ Builder, a SOAP server, a REST server, a database, a cloud service like backend as a service, and so on.
You could even open up other connections if you really need to. So, use a REST call to make a request, get some authorization, then open a socket to a client if you need to. There was a question in the Delphi session about that. Is it just JSON? And JSON is the standard way to move data back and forth over REST. But you can have binary fields in JSON and compressed fields. You can move images and movies this way, not streaming information, but files, etc. And then again, you can also create new or open ports or do whatever you need to support those other types of connections.
And again, for development, you are given an EMS development server and an EMS development console.
Right.
And you get 5 development licenses to do development and testing of your EMS server.
Yep.
And then contact sales, and they'll, depending on how many users you're going to have across an application that you're building, and also the deployment piece of the deployment console, analytics system, and deployment server.
Yep.
And then as far as for the future, right now it's ISAPI on Windows. What about EMS servers someday in the future on other platforms?
Yeah, next up we're working on an Apache module. And then following that, we've already talked publicly about our intention to build a Linux server solution, which obviously will run in Apache. So we'll be supporting Linux servers as a EMS deployment option.
Yeah. So you can scale by putting the EMS server on big machines, but also putting multiple EMS servers deployed to multiple machines.
And that's a great way to go. I mean, that's how it really scales with a stateless, sessionless type of approach in EMS.
Okay, other questions out there? I want to make sure, because we have JT's time here. And again, there's 2 more EMS sessions during this CodeRage. So
both are tomorrow morning, yeah.
Yeah, if you think of other questions between now and then, Marco and Jim Tierney will be able to handle those questions as well. Okay, otherwise, again, the question came through, yes, HTTP and HTTPS, and it's REST and JSON.
Yep.
Now, whether you want to send big blobs back and forth, sometimes what you might send is a a token or some kind of URI for an image or blob,
Right.
and then have your mobile app or your desktop app even go and request that piece on demand to grab it instead of sending everything down at once. You might
Right.
want to get your standard quote unquote traditional data and then populate. For example, if you've got bitmap blobs, you might want to start populating a list view, and then as you select something to get the detail, then you'd go and grab blobs and other things.
And you can do it piecemeal too. It is asynchronous. So like you may often see in a program like Google Maps where you see squares coming in at different timing. That's an asynchronous approach. So you can do the exact same thing with this type of technology.
So you have two choices. You can execute or execute asynchronous.
Right.
Yep. And again, it's all stateless. And DataSnap still is around for those people that are using and know DataSnap. DataSnap gives you all the options, including stateful, stateless, invocation, your own controls of lifecycle, and so on.
And DataSnap, of course, you need to build those services yourself. Where EMS is largely targeted is towards the enterprises that have to manage user access to this information. So that's kind of how to think about what's the right choice for me. If I'm building generic services that I don't know the number of users or know anything about them, DataSnap may be a better fit. If I'm building services where I'm getting information out of a SQL database behind my firewall and I want to restrict that to known users, EMS is the right solution.
So does EMS also fit if you're building application, let's say for a customer, they've got 20 users inside their firewall. If you're a consultant or a VAR, an ISV, and you're building a solution for someone, is that a good use for EMS is inside the firewall?
That's like probably the better use. I'd say it's not really meant for wide open public cloud type of usage. Because again, I think the best way to think about it is that, do I know the user? Do I need to restrict or manage his authorization and access to certain resources?
Yeah, and again, the other sessions, authentication, authorization with Jim and Marco with SQL and services that you want to connect to on the outside will give you a lot more. Okay, JT, thank you.